All right, this is the fun part. We're teaching derivatives, right? This is unit 2 of calculus. I am a little bit sick today, but I wanted to get this out. So basically, in my opinion, the best way in Calc BC, like courses like this, is to fundamentally understand what a derivative is and not to just like calculate it, like hear the product rule, you hear the power rule, stuff like that. You don't want to just memorize these rules. You want to learn what a derivative actually is. It'll make the course so much easier. So basically, let's just start out. So a derivative is like the fundamental concept of Calc 1, and it's your first semester of Calc BC. And basically, a derivative is just, you hear people say a slope of a point, right? It's the slope at one point. But what it actually is it's the slope between 2 points that are infinitely close to each other. So you know what a slope is, right? You draw 2 points, you draw a line through that. That's the slope. It's your rate of change. Now, as we move these 2 points closer and closer together, what will that slope look like? This is why limits are what you learned before. It's as these two approach each other, as the 2 points approach each other, what would the slope be? So now let's look at like a parabola, right? So if it's like a linear function, you know, there's a constant slope throughout the entire thing. If it's a parabola, there's no constant slope, right? There's nothing that you can just draw a line. It's the rate of change is constantly changing, is what I'm saying. But if we zoom in on a small section, you can see the difference between each of these is 0.001. It becomes more and more linear. That means if we draw 2 points here and we move them closer and closer to each other, it becomes more and more linear. This is the idea that we want, is as we keep zooming in and these 2 points keep approaching each other, then you can find what that slope is going to approach at that point. And basically, how we write this is we have this little what we call the definition of a derivative, and it looks like a bunch of like yap to you, but like we're gonna break this down, right? And this is what a lot of people don't do in calc is they don't break where this formula is from. Um, so let's start with your slope, right? We learned this in like pre-algebra, algebra 1, I'm not really sure, but it's m equals like the y2 minus y1 over x2 minus x1, right? This is just written a little differently. Function of basically your x is equal to b and x is equal to a, and it's function of b minus function of a. But it's pretty much just what this is, right? And that means your 2 points to find the slope instead of x1 and x2 is a in function of a and b in function of b. But what we want to do is find the slope between 2 points that are infinitely close to each other, right? So basically what we want to do is create the effect of which a is approaching b, or the other way around, same thing, b is approaching a, as these two x's approach each other. So here's what we're going to do, right? We're going to switch out a with the variable x, right? So instead of this a, we're going to make this x. And b, we're going to switch it with x plus h. And what we're trying to do, as you see in the future, is we're going to take the limit as h approaches 0. So both b and a become x. You see how it approaches each other because this h eventually approaches 0. Then naturally, f of a is going to be just f of x, right? F of b is going to equal f of x plus h. Right. So now we can simplify it out to this, like we can write it out, and then these x's cancel out, we get this. But remember, we still have to add the limit in as h approaches 0 because we want both point A and point B to approach each other. So now we have the definition of a derivative. And there's more ways to approach or to write like a derivative. It's this one, which is my personal favorite, f prime of x. There's dy over dx, or the more the actual way is the derivative of y with respect to x. I mean, this one I never liked because it was a lot of writing, and I don't want to write that much. And then just y prime, which is another one of my favorites. It's easy to write, just y prime. You also see d over dx, and a lot of the times people get confused, like, what is this symbol when you have dy over dx? D over dx is like, it's like a function. It's not a function. Sorry, it's like you doing something to a function. So if I have like 5x here, it means you're taking the derivative of 5x with respect to x. That just means you're taking the derivative of your variable, which is x. And there's one more way to write the definition of a derivative. This is your second definition of derivative. It looks a little different, but it's the same thing. It's basically your 2 points are x and f of x, and c and f of c, and you're saying as x approaches c. It's the same concept here, right? It is also important to know that when a point is differentiable, that means the derivative can be calculated of that point. When a point is not differentiable, so sometimes a point can be discontinued, okay, so sometimes a point can't be differentiable, and that's if it's discontinuous at that point, contains a corner, which is something like this, a cusp, which is like, I think something like this, I think, and a cusp, a corner, a cusp, I think are around the same thing, and then a vertical tangent line, which looks like this, because your derivative at that point is vertical, which is undefined. So if there's no definite slope at that point, it's not differentiable. Now we're gonna use our definition of a derivative to solve some of these problems. So we're trying to find the derivative of the function 3x minus 5. So I'm going to write down our formula first. So it's, give me a second. I'm just going to copy that down. And then basically what we can do here is, let's first substitute in f of x and f of x plus h. So f of x is easy. We just plug in this little part. What's f of x plus h? Well, it's also easy. You just plug in x plus h for wherever you see the x. So basically that'll be like 3x plus h minus 5, which is 3x plus 3h minus 5. So we can just plug that in. Minus 3x plus 5 over h. Just draw a line straight through that over h. These cancel out. These cancel out. You get limit to h approaches 0 of 3h over h. Limit of h, and then you can just simplify these, and you just get we're just gonna write 3. The answer is 3. Cool. Okay. Oh my. Let's take a look. Okay. Okay, second question. So now we're going to take the derivative of this function using the definition of a derivative, and then find the equation of the tangent line. Tangent line is basically a line that only touches the function at one point, and it's important to note that the tangent line is just wherever it's just the tangent line has the slope of the derivative at that point. So first, let's review our point slope formula. Y minus y1 is equal to mx minus x1. So basically what we want to do is find the coordinate at x equals 2, and then find the slope at x equals 2. And we just plug it straight into our formula. So let's first get the easy part out the way. What we're going to do is find the point at x equals 2. Find the coordinate, right? So we just plug in this, right? We just plug in 2 for x, and we got 4 minus 6, which is negative 2. So then our point is 2, negative 2. Next, we're going to use our definition of a derivative. So first we're going to do f of x plus h. It's just x plus h squared minus 3x plus h. Let's simplify that down. Is that right? There's 2xh. 2xh, that's better. Minus 3x minus 3h, right? And then we can just put it into our definition of a derivative. Minus 3h minus x squared plus 3x, right? Cancel. See, the point of these is it cancels out, right? So then we're left with, over, oh my, so much work, over h, and then we're just left with limit as h approaches 0 of 2xh plus h squared minus 3h. And then these cancel out, so we're left with 2x plus h minus 3. H approaches 0, you get 2x minus 3 is your y prime. So it's basically, we're going to write the same thing, but we're going to write f prime of x. Same thing. The reason why I do that is because we're plugging in x equals 2 later, because we're trying to find the derivative at that one point. F prime of 2 is equal to 2 minus 3, which is 4 minus 3, which is 1. So then our slope is 1. Y plus 2 is equal to x minus 2. Now, see how this one we got 3? Because there's no x's there. Well, why is that? It's because if we graph 3x minus 5 out, notice that the slope is always going to be 3. That means the derivative, no matter where we are, that is always going to be 3. And that's why it's constant. So that's just kind of an introduction on derivatives. And yeah, I'll see you next time.